Bismillahirrahmanirrahim. We were about to do question number 5. Find the LCM of 2x raised to power 4 minus y raised to power 4 3 into this expression, okay, by factorization. How do we find it? First of all, what we are going to do is, as we have discussed earlier, we are going to factorize all these two expressions, okay, all the expression that is given to us. After that, we are going to pick all the different factors from those expressions, and then we will raise them to their highest power. So this is how we find the LCM. So first of all, what we are going to do is we are going to factorize these expressions, okay. Let me take the first expression first. It is 2 into x raised to power 4 minus y raised to power 4. Okay, if I factorize this, we know that this is the difference of two perfect squares. So whenever we have the difference of two perfect square, what do? We do is we use the formula a minus b into a plus b. Okay, this is the formula that we use. Now if I write it in the form of square, we know that x raised to power 4 is the square of x square minus y raised to power 4 is the square of y square. So it is going to be, in place of a we have a square, in place of b we have y square. So it's going to be a minus b into a plus b. Okay, and we know that out of these two, this factor can be further factorized by using same formula. Again, we have two perfect square having a minus sign between them, so it's going to be x minus y into x plus y into x square plus y square. So this is the factorization of the first expression. Okay, let me name it as first. Okay, this is the first expression in factorized form. Now taking the second expression, which is x cube plus 2 x square y minus x y square minus 2 y cube. Okay, lower the volume, thoda sa volume kam kar. Okay, what we do is we are going to take common from these two. We know that x square can be taken common from the first two terms, so it's going to be x plus 2y. Over here we can take the minus sign common as well as the y square. Okay, so we are going to get x plus 2y. Okay, so after we have taken x square from the first two terms and y square from the last two terms, and as well as we have taken minus sign common. Okay, so what do we get here is x plus 2y. Taking x plus 2y common, we will have x square minus y square over here, and this can further be factorized by using the same a square minus b square formula. So now the next step is to find the LCM. Okay, this is the second expression in factorized form. So we have factorized both the expression. Now it's very simple to find the LCM. What you are going to do is, as I have explained earlier, you are going to pick all the different factors appearing in this expression, and then you are going to raise them to their highest power. Okay, for example, we have 2 over here, okay, and 3. These are the two numbers that we have in both the expression. Then we have the factor x minus y, okay, x plus y, and x square plus y square, and the factor x plus 2y. Let me start from here so we have complete full line. Okay, I'm going to write that again. LCM will be LCM is going to be 2 into 3. Okay, then x minus y is a factor. Write all the factors that you see. Okay, x square plus y square and x plus 2y. Okay, these are all the different factors that we x minus y. I have already written, x plus y is already written. Okay, so write down all the different factors, and the next step is you just have to raise them to their highest power. Okay, we know that 2 has the highest power of 2 is 1, of 3 is also 1, so it's going to be 6. 2 into 3 6, and then x minus y to the highest power is, we know that the highest power that is involved is 1. Okay, if you had square or cube over here, I would have picked that. Okay, so always take the highest power of all the factors. Okay, x plus y X plus y has power 1 here. Here is also 1, so I have taken 1 power over here. X square plus y square has also power 1. X plus 2y is also the highest power that we can see is 1. Okay, we have no other exponent of x plus 2y which is greater than 1. So you can also then at the end you can multiply these factors or just leave them like that. Okay, in both the cases the answer will be correct. If you have time, do multiply them. If you don't have, you can leave it like this. Okay, so this is the LCM. How you find the LCM? By factorization. Factorize both the expressions, write down all the different factors and raise them to their highest power. These are the three steps that we do while finding the LCM. Okay, and this completes question number 5. Now let's move to the next question. Now in this question, they have asked for what value of k will x plus 4 be a HCF of this expression and this expression. So they have given us two expressions, and they have given us that x plus 4 is the highest common factor of both the expression. Okay, so we have to find the value of k which satisfies this given situation. Now, as it is given in the question, x plus 4 is the HCF of both these expressions. So I can take any one at a time. Okay, for example, what happens if we take the second expression? Okay, they have given us that it is the HCF of this expression as well as this expression. So you can use any one of these expressions. Suppose if I pick 2, then x plus 4 is HCF of this expression, means that it is the highest common factor. It means that x plus 4 is a factor of this expression. Now in the previous videos we have learned the videos about the remainder theorem and the factor theorem. From that videos we know that if any linear factor is any linear divisor is a factor of the expression of the polynomial, then the remainder must be equal to 0. Okay, so according to the factor theorem that we have already learned, according to factor theorem, if x plus 4 is a factor of this expression, then it means that let me name it as p of x. Okay, so if x plus 4 is an expression of this polynomial, then it means that p of negative 4 must be equal to 0. This is from the factor theorem that we have already learned. Okay, so p of negative 4 means that if you put negative 4 in place of x, then it must be equal to 0. Okay, this is p of negative 4, and this must be equal to 0 if x plus 4 is a factor of this polynomial, and it is given in the question that x plus 4 is a factor of this polynomial. So what we are going to do is, I'm going to put this equal to 0. 2 into negative 4 whole square will be 16 minus 4 k minus 12 equal to 0. Now if I make use of the calculator, 2 into 16 will be 32. Okay, 32 minus 4k minus 12 equals to 0. So 32 minus 12 will be 32 minus 12 will be 20. So negative 4k plus 20 equals to 0. This implies that 4k is equal to negative 4k is equal to negative 20, and k will be 20 by 4, which is 5. So k will have a value of 5. Okay, and this completes the solution, because we had to find that value of k for which x plus 4 was a highest common factor of this polynomial. If it is a highest common factor, it means it is a factor, and we know that whenever a linear expression is a factor of the polynomial, then from that we can take a. Okay, a in this case is negative 4, so p of negative 4 must be equal to 0 if x plus 4 is a factor of the given polynomial. We used this fact and found the value of k, and this completes the solution of question number this was question number 6. Now let's move to question number 7. In question number 7, question number 7 is not included. Question number 8. Okay, now for the next question, first of all we should learn the relation between L.C.M and H.C.F. Now suppose you have two polynomials. Let those polynomials be p of x and q of x. Okay, suppose you have two polynomials, and you found its HCF as well as LCM. Okay, let its HCF be equal to h Okay, and let the LCM be equal to L. Then the theorem that I'm going to state here is that, and which we are going to use in question number 8 and 9, is that the product of HCF and LCM is always equal to the product of the polynomials, okay, of whom HCF and LCM we have found. So the product of HCF into LCM is always equal to the product of these two polynomials. Okay, so what do we have? We have two polynomials. We found its HCF as H, and we found its the LCM of both the expression as L. Then the relation between HCF and LCM is that the product of LCM and HCF is always equal to the product of these two polynomials whose LCM and HCF are H and L. So in short form we can write H into L is always equal to P of X into Q of X. Okay, so this is the theorem that we are going to use in question number 8 and 9. Let me write the question. Now in question number 8 we have the LCM and HCF. The LCM and HCF of two polynomials P of X and Q of X are 2 into x raised to power 4 minus 1 and x plus 1 into x square plus 1 respectively. So the LCM is 2 into x square, x raised to power 4 minus 1, and 2 times x raised to power 4 minus 1, and HCF is x plus 1 into x square plus 1. It is given that P of X is x cube plus x square plus x plus 1. You have to find Q of X. So over here what do we have is we are given the LCM, the HCF, okay, and we are given one polynomial, and we have to find the other polynomial. As I have told you, we know that the product of HCF into LCM is always equal to P of X into Q of X. So over here we are given H, L, and the one of the two polynomials. We have to find this Q of X. In order to find this, I am going to shift P of X to this side. So we will have the formula Q of X is equal to H into L over P of X. Okay, so putting the given values in this expression, what do we have? H is x plus 1 into x square plus 1 into LCM is 2 into x raised to power 4 minus 1, and we have to divide it by this expression x cube plus x square plus x plus 1. Now this expression is factorizable as well as this expression. So what am I going to do is I am going to factorize this expression, which will give me, this is a square minus b square formula, so this is going to give me x square minus 1 into x square plus 1 as factor, and then once again when I factorize this x square minus 1, and let me do it in the next step. Now to factorize the denominator, I will take x square common from first two terms, and I am going to get x plus 1 plus x plus 1. Now x plus 1 into x square plus 1 into 2. Over here x square minus 1 will be x minus 1 into x plus 1 into x square plus 1 over we will have x square, and after I take x plus 1 common from here, we are going to get x plus 1 into x square plus 1. Okay, I have factorized this denominator and I have factorized this factor, and the factors are these. Okay, so in the next step what am I going to do is I am going to cancel the common factors. For example, x plus 1 will be cancelled out by x square plus 1, x square plus 1, and x square plus 1, x plus 1 will be cancelled out, and we will have 2 into x minus 1, x plus 1 into x square plus 1 as the next polynomial. So after multiplying this, what am I going to get is x square minus 1 into x square plus 1, which will be 2 twice of x raised to power 4 minus 1, and this will be the answer. So the next polynomial will be twice of x raised to power 4 minus 1. Okay, this will be the answer. Now the next question is they have given us two polynomials, okay, and the HCF, and we have to find the LCM again by using the same theorem. HCF into LCM, we know that it is equal to P of X into q of x. So putting the values, we have to find L, so L will be P into Q over H. So I'm going to filter these values into this formula. For that, 10 x square minus 9 x square minus 3x plus 2 into q of x, but I don't have enough space, so I'm going to start from here. L will be equal to P is 10 x square minus 9 and Q is 10x x plus 3 x minus 1 whole square over over H.C.F, which is 10 x plus 3 and x minus 1. Now as you may see, 10 will be cancelled out with 10, x plus 3 can be cancelled out with x plus 3, and x minus 1 will be cancelled out with one of these, it is x minus 1 whole square, so one of the x minus 1 will be cancelled out, and we will be left with x minus 1 only. So the remaining factors, LCM will be 10 into x square minus 9, x square minus 3x plus 2 into x minus 1. Okay, so this is the LCM. Now if you want, we must factorize this because it will have a factor x minus 1. So we will have 10 into x square minus 9, and after factorizing this, what do we get is, I think, x minus 2 into x minus 1. X square minus, yes, the factors of these by midterm breaking will be this x into x minus 1. So LCM will be 10 x, I am writing this x in the beginning, okay, and x minus 1 whole square will be, this will be x minus 1 whole square, then we are going to have x minus 2 and x square minus 9, okay, and this will complete the solution. This is how we found the LCM when the two polynomials were given and HCF was given. So by using the same formula, what we did is we factorized this, we just cancelled out the same factors and then we multiplied all these factors, and this is how we obtained the LCM. So this completes the exercise 6.1.